Hi, my name is McKinley Fox, and I have been conducting research with fellow Lyon College student Kaleb Newcomb. Also shown here are our mentors that have been helping us to conduct this research. As the title describes, we have been extracting and analyzing rice bran oil from different types of rice bran for health benefits. This is a picture of me and our HPLC machine at Lyon. I just wanted everyone to know who is giving this presentation. And just a little bit about me. I am currently a senior at Lyon and I hope to attend medical school next year. Okay, first I'm going to talk about how we extracted the oil from the rice bran. We started by first weighing out a sample of about 1 gram of a type of rice bran. This was done with the analytical scale to ensure accuracy. We then placed the sample of rice bran into a CHR tube and added 30 milliliters of hexane. The solution was then mixed using a magnetic stir bar and a magnetic plate for 10 minutes. The purpose of this step is to separate the rice bran oil from the rice bran. Because the rice bran oil is nonpolar, it will dissolve in the hexane when the solution is mixed. The hexane and rice bran oil were then separated using vacuum filtration. Once we poured the solution through the vacuum filter, we washed the rice bran with 5 milliliters of hexane twice to ensure that we collect all the oil we extracted. Finally, we dried the oil with argon gas to evaporate off the hexane and obtain a sample of pure oil. The next step in this process, which we're still currently performing, is using high-pressure liquid chromatography to quantify how much of certain fatty acids are in these different types of rice bran oil. I just wanted to explain a little bit about what our HPLC machine does before I explain our results. We have a reverse phase HPLC, which means that our mobile phase, or our solvents, which are sitting on the top of the machine in that picture, are polar. We use both acetonitrile and water as our polar solvents. The stationary phase in our analytical column is nonpolar. This means that nonpolar solutions will tend to stick to the stationary phase, and polar solutions will be pushed out of the column faster with the mobile phase. The mobile phase that we are currently using is an isocratic method that consists of 15% water and acetonitrile during the whole time the solution is being ran through the column. The whole process takes about 23 minutes to run one sample through the column because we have about a 3-minute pre-run period where our column equilibrates, and then we have a run of our actual sample through the column of up to 17 minutes, and then we have a post-run of 3 minutes. And this picture at the bottom is just what I thought was a nice diagram, and it kind of shows how samples are injected into the column and how different components in our samples are detected. Okay, and these are just some examples of chromatograms that we have actually obtained. And the first chromatogram shows our fatty acid standards dissolved in acetonitrile. This did give us good peaks, but we had to dissolve the standards in a nonpolar solvent because the peaks were not showing up well when we ran our actual rice bran oil samples that were dissolved in acetonitrile also. The sample was exiting the column too quickly before it could be detected because of how polar the acetonitrile is. The second chromatogram shows our standards and one sample of rice bran oil dissolved in hexane, and hexane is a nonpolar solvent. This solvent did not give us quite as nice of peaks as you can see by looking at these chromatograms, but it did give us a better retention time for our sample so that we could easily compare the peaks of our sample to the peaks of our standards. Rice bran oil has many unique properties and a wide range of health benefits that can be utilized in food, pharmaceutical, and chemical industries. These health benefits include lowering low-density lipoprotein levels, which is also known as bad cholesterol, because these lipoproteins deliver cholesterol to tissues. This in turn then decreases the risk of heart disease, because the risk of depositing unwanted cholesterol is lower, and therefore you have a lower risk of forming atherosclerotic plaques. These desirable benefits can be attributed to the polyunsaturated fatty acids found within the oil. Linoleic and linolenic acids are not only polyunsaturated fatty acids, but they're also essential fatty acids that are obtained through the diet. And they actually have many important bodily functions. They allow us to store energy in the form of triglycerides, they allow us to form parts of cell membranes, and they also allow us to form important biological signaling molecules. To conclude, we are performing this research to create a thorough procedure that can determine which fatty acids are present in rice bran oil so that it can then be determined which rice bran oil is the most beneficial to overall health. Thanks.